In photosynthesis, plants use the energy and sunlight to absorb carbon dioxide from the air and combine it with water to create sugars to use for growth. In the process, they release oxygen and store the carbon in their tissues, including the roots. It's gradually released as the plants grow and when they die and decay. But some carbon stays in the soil. This inspired scientists from the Salk Institute in San Diego, California, to program plants to make more stable forms of carbon, which would be stored long-term deep in the soil.
When I was a child growing up in western Pennsylvania, I was an avid gardener. My grandmother and great-grandmother taught me to have a vegetable garden every summer. And then that progressed into an extensive composting regime. And I'm 54 years old, so this is back in the 70s. And I do remember from my childhood trying to put cork, because I knew it was a natural substance. So when my parents or friends of theirs had wine and they pulled the cork out, I knew it was a natural substance. I thought it was just like wood, but a slightly different form. I put it in my compost heaps and it never decayed. And so that kind of came back to me when we started to think about plants.
Cork contains a high level of suberin, a waterproof waxy substance found in most plants that prevents roots from decomposing. It's this quality that scientists hope to use to keep carbon buried underground and, well, to save the world.
That enriches the soil. So it turns out that by leaving some plant carbon behind in the soil, the plants actually grow better. So an ecosystem or a farmer's field, etc., that has a higher carbon content in the soil is a healthier environment.
Today, scientists are working to create mechanisms that would allow plants to produce more suberin. Salk Institute labs imitate various climate zones to find a perfect plant for each region. This process takes time and energy. Recently, the Institute purchased a robot that in one day does more than a team of scientists can accomplish in 5 weeks. They're using conventional breeding to create crops that are carbon storage powerhouses, but may one day use genetic engineering.
In our project, we basically are very open. So we use the natural variation, the natural genetic variation that exists in natural strains to increase the amounts of suberin. So we are not necessarily in need to use genetic engineering. However, if we were to use genetic engineering, it would be much faster. I think it will be a very interesting question in the future whether the pace of climate change can wait for traditional breeding.
In the next 5 years, the scientists plan to have an array of plants for different regions that would help lower the level of carbon dioxide in the atmosphere. The effect wouldn't be felt for another decade or two, but the scientists say they hope by then humanity will have figured out how to slow down climate change. Genia Dulot for VOA News, San Diego, California.